we want to find the derivatives of the given functions involving inverse trig functions. The derivative formulas are given here below, but notice how there are two derivative formulas involving arc sine and two derivative formulas involving arc cosine. The reason there are two derivative formulas is because these two derivative formulas are for the basic arc sine and arc cosine function, where it's not a composite function, and these two derivative formulas include the chain rule, where u would be equal to the inner function. Notice these two derivative formulas involve a product where the first factor is the derivative of the outer function, and u prime is the derivative of u, which is the inner function. So now that we've learned the chain rule, we always need to be aware whether the given function is a composite function or not. The good news is, if it's not a composite function, and we try to apply the chain rule, we'll still get the correct derivative because u would be equal to x, and u prime would be equal to 1. So looking at our first function, we have f of x equals 3 times inverse sine of x, or if we want 3 arc sine of x. So because we have inverse sine of x, this is not a composite function, so we can go ahead and use this derivative formula here to find our derivative. F prime of x is equal to 3 times, we would just have 1 divided by the square root of the quantity 1 minus x squared. So f prime is equal to 3 divided by the square root of the quantity 1 minus x squared. Now again, I do want to emphasize that even if we did try to apply the chain rule to find this derivative, the inner function u would be equal to x, and therefore u prime, the derivative of u with respect to x, would be 1, giving us the same derivative. Next we have g of x equals 4 times inverse cosine of 3x squared, or 4 arc cosine 3x squared. Notice how this is a composite function, where the inner function is 3x squared. So to find g prime of x, we do have to apply the chain rule, which means to find this derivative, we would have to apply this derivative formula here, again where u is our inner function. So if we let u equal 3x squared, notice that u prime, the derivative of u with respect to x, would be 6x, which means g prime of x would be equal to 4 times the derivative of the outer function, which would be negative 1 divided by the square root of 1 minus u squared, or 1 minus 3x to the second squared. This is the derivative of the outer function times u prime, which is the derivative of the inner function, which we know is 6x. Now let's go ahead and clean this up. We have g prime of x equals, this would be negative 24x divided by the square root of 1 minus 3x squared to the second would be 9x to the fourth. And this would be our derivative function. So going back to our derivative formulas just for a moment, I notice that some textbooks don't use these derivative formulas here where the chain rule is included, in the derivative formula, but I actually prefer the derivative formulas in this form here because it emphasizes how we always have to be on the lookout for composite functions where we have to apply the chain rule to find the derivative correctly. I hope you found these two examples helpful.